Okay, welcome back. This is the ninth lecture of the G30 International Program of the Nagoya University. This is the final lecture for the G30 program. Of course, later we will support the other lecture for the inverter and motor drive and some power electronics technology. But the first chapter, this is the G30 program, international program. So this is the conclusion lecture. Okay. First step, and we have learned total systems for the driving because of the G30 program is the Automotive Applications Areas Learning System curriculum. So that our target is the DC motor drive. For the DC motor drive, we have we have prepared some experimental setup for the trains toy. If you like, please come in our laboratory, Nagoya University Power Electronics Laboratory, and we have checked the trains toy. And connect to the railways toy, and if you input the actuator, the voltage is higher, and we have obtained the pulse width, increasing pulse width performance, and through the drive circuit, we can obtain the wide width pulse for the boost chopper. In case of the wide width boost chopper, output voltage, output voltage V out, and in the V in, V out equal is T off term and T on plus T off V in. We can obtain this term. So in case of the term on term is an increase. This T off term is decrease, so we can obtain the higher voltage. In case of the output voltage higher, the train's speed is higher. This is a very simple automotive applications for the power electronics axle control. Principle, only the principle. However, in the real automotive application, we have obtained, for example, this Avis DC converter. Not control the motor drive. Motor drive is already applied for the AC drive, AC motors. So AC motor for the Japanese hybrid system is batteries, main batteries, DC-DC converters, and obtain the higher voltage, and through the inverter, and we can obtain the AC alternating current, output voltage at current, and we can drive the AC motor because the output drive three-phase AC motor. So we can obtain the power, output power for driving by electric power. Okay, boost chopper and inverter. This is a Prius and Yaris and some Toyota's famous. In case of the Honda is the Accord and fuel cell type quality. They have uh, they have included boost chopper and inverter. This I mean this boost chopper, or the in case of the 48 volt Mercedes S class and C class Audi's SQ7, some system have the 12 lead acid and DC-DC converter and 12 volt, 48 volt lithium battery. And using this board and inverter and drive, we can obtain the electric power for driving, torque assist driving. But however, in case of the Prius, the voltage is 600 volt. However, in case of the Europeans, mild hybrid electric system is the only driving for the main driving is the engine, using the engine. So 48 volt is the torque assist. So the around the 10 to 12. Audi's one is 22. Max power is 22 kilowatt motor driving. However, this type is obtained higher voltage, higher power, around 50 to 100 over kilowatt power. However, in the real type automotive area, we must prepare the DC-DC converter because the lower lithium battery 20 kHz, but the inverter side required higher voltage, so boost chopper is required. One example, and otherwise the 20 volt type, and for motor driving required higher voltage, so we require the boost chopper. This boost chopper we have mentioned this SQ7 DC-DC converter. Inductor is here. Inductor is parallel connected 4 phase. So the inductor is 1, 2, 3, 4 type inductors. Power semiconductor is under this inductor, and control circuit. Control circuit is here, like here, or opposite side of this PC board. This type is here. Okay. We in the automotive area, the power electronic system, in case of the DC-DC converter, we must obtain the constant voltage for the output voltage DC-DC converter side. Constant voltage required. Constant voltage required. So we must obtain we must prepare for the control side for the feedback loop. So we must run the feedback control scheme, and this the knowledge, okay? And the output voltage increase detection and compare the reference voltage, and this is the invert side, lower side, and compare to this one, and lower higher side, the timing is pulse width increase, but the lower side increase the voltage. This inverse side decrease, and decrease means turn T on, width is decrease. Decrease means the lower side because of the decrease, and this one as voltage decrease. So we can keep higher side this control or the lower side, higher side, lower side. So we must obtain the keep constant to the output voltage. Okay. So we must run this control side and board plot and frequency characteristics, some principles and analysis methods we must run for the power electronics total systems. But we have only the input side gate of the power electronics. But please image and please obtain some image and how to drive the primitive power electronics systems faster. If you interest the power electronics, for the next step, we will prepare some inverter and some converters and Ph.D. converters, some other power electronics real technology. We will lecture in the next chance. Okay. So thank you for checking your sharing your time for our lecture. See you. ありがとうございました。